This webinar is sponsored by NEC Corporation, a $37 billion technology leader with over 100 years of innovation. Their ProgrammableFlow Network Suite was the first commercially available enterprise-class SDN solution to leverage the OpenFlow protocol. Thank you for your time and interest in NEC's ProgrammableFlow Network Suite.
This sponsored webinar is one of many IP Space Data Center webinars. You can register for live sessions, buy the recordings, or get access to all of them with a yearly subscription. For more information, visit ipspace.net/dc. This one is for you, Samrat. What's the forwarding capacity of the controllers?
Yeah, the forwarding capacity of the controller depends upon the server and the NIC capacity. Our controller can scale very good in terms of processing the packets. So effectively, if you have good CPU and memory, particularly the memory and the good NIC bandwidth, so you should be able to forward almost into the 80% capacity of the NIC.
Next one, does clustering means adding clustering protocol between PFCs? If not, how is the persistency maintained?
Sure. So for clustering, the controller uses NEC's clustering technology, and as you perhaps know, NEC is a leader in the server space. So we use a special memory synchronization also, which means that all the states which is kept at any of the controller and the states reflect the flow table entries are synchronized at a memory level with the second controller, the backup controller. And what it means is that any controller, if it goes offline, the other controller comes up with the state space rapidly. That means there is hardly any delay or gap in terms of switching over from one controller to the other controller.
Which also answered the question whether the protocol between them is standard or proprietary. Then we have a number of questions regarding the control plane protocols. So how does the OpenFlow network interact with the outside world like OSPF or BGP? It doesn't. It uses static routing, and later on I'll show you in which use cases this is not a problem. Can this switch do LACP to servers? Samrat, I think the answer is no.
Yeah, what it
Right?
provides lag, and you can set up load balancing based on IP hash or MAC hashing, but it does not provide the exact LACP in terms of the monitoring part of it. It takes care of link level. If link goes down, it will take over the other link, but I think it doesn't support the LACP protocol as such.
This is what people would call static port channel. And in the virtualized environment, it might not even make sense to have port channel toward a server. So toward a bare metal server, it absolutely makes sense to do so. In VMware or Hyper-V environment, it might make more sense to have individual VMs assigned to individual uplink ports, and then the controller would sense that because it will see the MAC addresses coming from the hypervisor hosts.
One more thing here is in connecting any virtual VM or ESX or any of the hypervisor to the next level switches, even though we do not have the LSP, what we have is a multi-switch lag. I think you're probably going to talk about it later, that you can connect to more than one switches. So it takes care of not just the link, but the switch level failure as well.
There's another one. What about VMware?
Yeah, right now the VMware vSwitch does not support any OpenFlow control like, let's say, your Hyper-V switch or the OVS. So the way to use it, essentially, we can map the VMware vSwitch port groups VLAN into the ProgrammableFlow network, and that's something Ivan is going to talk about later. And that's the only way. It's basically like a legacy switch connecting into an OpenFlow network, where the legacy switch is the vSwitch does not participate directly with the controller.
Now, we have a number of questions regarding the flow entries and full flow entries. Okay. As you know, if you were reading my blog posts, one of the major problems of any OpenFlow solution is the flow scalability. What you have to do if you want to have a scalable solution is you have to do as much as possible on the edge and as little as possible in the core. This is exactly what a programmable flow controller is doing. So later on, you'll see how the virtual networking works, and you will see that we can do layer 2, layer 3, and layer 4 with policy maps or packet filters or traffic redirection. And actually, what goes on behind the scenes is that PFC is computing the optimal flows based on your configuration and downloading them into the ingress edge switch. So the ingress edge switch is doing most of the heavy lifting, and then it marks the packet in some cases. In other cases, the packet is forwarded through the network based on the MAC address. So if it marks the packet, think of it like MPLS. It does the classification, it figures out what the path across the network is, it marks the packet, it sends the packet across the network, and the only thing that the network has to do is just forward the packet along the path until it gets to the egress port. So all of the heavy lifting is done on the edge switches, which is why this thing scales, because the core switches don't have the full 5 or 7 or whatever tuple OpenFlow entries. The core switches just forward based on a few bits in each individual frame. And the other set of questions was about A and B and how we know where A and B is. In this particular case, I was assuming that B was previously known. If an unknown A is sending a packet to an unknown B, and they are both in the same layer 2 segment, then the only thing we can do is flooding, unknown unicast flooding. And yes, we can do it, and way later I'll show you how that's done. So I assumed here that B was known. Then the next set of questions was along the lines of, so does the first packet of every flow has to go to the controller? And the answer is no. Only if the controller didn't know about A before, then when the A sends the first packet, it goes to the controller. And at that time, the controller has to analyze the model of the virtual network to which A is connected. It has to figure out what happens to packets sent by A and downloads a number of OpenFlow entries into this edge switch. And obviously, the complexity of these entries depends on the complexity of your virtual tenant model. And we'll see later on what that is. So it doesn't mean that all the TCP SYN packets would be sent to the controller. Only when A is unknown is the first packet sent to the controller, and then if the topology of your network, virtual network, is simple, then the controller can pre-configure all these switches so that the new flows are automatically sent, let's say, between A and B. But of course, if you have configured some really weird packet filters, then maybe individual packets of other TCP flows will also go to the controller. And then there are a number of questions regarding IPv6 and other things and OpenFlow 1.0. As you already guessed, programmable flow switches are OpenFlow 1.0 switches, which means that the protocol on the wire is OpenFlow 1.0. Most of the things that we will be mentioning in the next slides, like IPv6 or QoS or flooding control, are vendor-specific extensions. The next question, can you mix OpenFlow controlled switches with traditional switches in the same network? The answer is yes, if the traditional switches are here on the edge and the OpenFlow domain is contiguous. Next question, also for you, Samrat, what's the number of flow modifications per second for the edge switch?
It is typically in the range of hundreds between the controller to the switch. The number is not limited by the controller capacity, but by the switch CPU capacity and the number of messages you can send from the controller to the switch. So effectively, raw is around the hundreds, but the maximum it can reach is like 1,000 flows per second.
And a few easy ones is the control network, one large layer 2 domain. If I'm not mistaken, each control plane switch is one IP subnet, right?
Yes, the entire control plane, if you're talking about the secure channels, the management can belong to a one single layer 2 network.
And maybe, Samrat, just to give people a bit of a perspective, what's the biggest network you would build with the programmable flow switches?
Typically, a single controller can support up to 100 switches. The numbers comes by the number of MAC addresses, which it can support up to 200,000 and more. So that gives us an idea of the number of VMs you can connect to that network.
Another question, just to confirm, OpenFlow switches have to be contiguous? Yes. Next one, how does the switch and the PFC detect the break in the network? Now, there are two types of breaks. One is in the data path over here. And in this case, you can use the usual loss detection mechanism. And the other one is between the switch and the controller in the control plane network. And there you have to use OpenFlow or TCP keep alives. Interesting one, can the PFS 1000 work with a non-OpenFlow physical network?
PFS 1000 is just like a OpenFlow switch. It can only be controlled by a controller and can only participate in an OpenFlow network.
So you cannot use it as a standalone switch on Hyper-V?
You can, but it will be just like one switch point then, still controlled by the controller.
Okay, next one. Does controller of controllers exist to manage centrally distributed offices?
At this point, we have a way to manage multiple controller from a control and visualization point of view, but not where we are essentially creating a single controller domain from a state space. And that, I think, that is in the product roadmap.
The next one, does NEC plan to support Open vSwitch in the future?
Right now, we support Open vSwitch, but not as a product level support.
So it works, but it's not supported.
Exactly.
Oh, this is a good one. Is the original packet in my scenario here on the slide queued on the first hop switch until the flow is propagated to all relevant switches? Actually, no. What's going on is that as the first packet is sent to the controller does two things at once. It starts downloading the flows into all the switches, and it sends a packet out message to the final egress switch to send the packet to the destination. So packet comes in, goes to the controller, is sent to the final switch and out. And that repeats until the flow entries are set up in the intermediate switches. So you have, if you wish, sort of process switching, as Cisco IOS fans would say. And then when the entries are downloaded, then you have the silicon-based switching. An interesting one on the interoperability. Can we use a lot of different vendors in our network and manage it with the one, let's say, programmable flow controller? So Samrat, what other vendors would you support?
So far, we have shown in public demonstration that we have worked or interworked with IBM Switch, Brocade, then Extreme, the Intel Fulcrum platform, at least what I know of. And there are other vendors which we are working with, which is basically not much about that we cannot. At this point, all we need is a support of full support of OpenFlow spec 1.0 to provide all the features which we'll be talking about in the next stage.
Okay, I think we already answered the question, can controller be distributed? I would say no. Even if you're running in a cluster, you still have to have them pretty close together. question from Isabel. How about interoperability with other vendors' controllers?
Yes, so at this point of time, the OpenFlow Network Foundation, the standard body, has not defined anything how two controllers can interwork, but I hear that that is in the charter. So right now, a single controller can only control its domain, but the controller cannot talk to another vendor controller for peering or any other type of such functionalities.
Can an OpenFlow network have multiple controllers controlling different parts of the network? In theory, yes, but then you would actually build different OpenFlow networks, and you would have to interconnect them using whatever standard means of internet connecting networks you want to use. What are the measures taken to protect the security of the PFC? The first thing that is in place is the control plane network. So PFC is only reachable through the control plane network. And control plane network is totally isolated from the data network.
No, that is right. And also, in terms of accessing the PFC, it is over the SSH. And then one can, of course, add any other best practices to secure the PFC.
Can the controller make flow decisions based on link utilization?
Yes, it does. Flow decision, it does that because it uses the ECMP as well, and it can go up to 8-way ECMP. And in order to use the multipath with the 8-way ECMP, it actually does see the load in terms of the flows, and then accordingly maps new flows into new paths. So in this case, it's one of the scenario where the flows are deployed based on the load of the network.
If you have questions after watching this video, send a tweet to @iOSHints or send me an email using contact form on ipspace.net, where you'll also find information about other data center webinars. For all commercial questions and programmable flow evaluation requests, please contact NEC.